Hi, this is Max Wilganowski. This is going to be the video tutorial explaining our being me and Matthew's Engineering Grand Challenge project. The topic we chose was over solar energy, so let's go ahead and do some background on it. So solar energy is being used, or being thought of being used as a substitute to traditional fossil fuels, but there are three key problems with that right now. They're highly inefficient. In laboratory settings, they only reach efficiencies at 30 to 40%. Outside of that, it's 10 to 20. The next problem is manufacturing costs, because the metals need to be pure so that they can be more efficient. That increases the cost of manufacturing. That kind of goes hand in hand. And then the last problem is storing solar energy produced by solar cells, because if there is not a sun, we need to be able to store and use stored energy later. So yeah, those are the three problems. Let's go ahead and look at the algorithm. Right here, the problem statement is in short saying that there are going to be three options. We're going to calculate the percent difference between two renewable resources over a 20-year period in our data set. If not that, we are going to compare the usage of a resource throughout the 20-year period. So we're only going to use one cell divided by one energy value in one cell divided by the total renewable energy in that 1 year times 100. And then we're going to do the same thing with non-renewable energy. And then the last option is going to ask the user to have a minimum and maximum boundary input as a vector. And then it will search through the matrix and find any energy value that falls in that bounds, print the resource name associated with the row number, and the year associated with the column, and the energy in the cell. So some assumptions we're going to make when loading in the matrix is that it will be loaded correctly. We're not going to do any validation on that. And that the rows are going to be static. This assumption is made because we mostly don't expect users to input non-renewable energy data, because this is supposed to emphasize the need for renewable energy. We're also going to assume that whatever data gets entered, the resource that each row is respective to will stay the same. So like biomass is 1, that will always be 1. Biomass will always be 1. Same goes for every other thing. So we're going to jump right into the code because I feel like that explains the algorithm better. So we have this loop right here. This is set to 0, and then this while loop will ask the user at the very end, after each option, if they want to compare data again. It will ask you to do this first entry right here, which is selecting which renewable resource you'd like to examine. Excuse me. And then we have this resource right here. We can afford to do this because we're keeping our row static. Each entry is respective to its row number. This is made so that outputting is easier. And we have the year array. This was a little bit of hard coding. This can be fixed by using an input asking the user what is their first year, and then incrementing by 1 up until we have years, the amount of years equal to the amount of columns. This is loading the data. This is using the fact that our rows are going to be static. We have the non-renewable plus renewable energy in a vector, and we have just the renewable energy total in a vector. This also makes outputting easier. We also have all our units are going to be in the British thermal unit to the quadrillion as our input. Outputs typically are going to be percent until option 3. So let's go ahead and start cracking down this code. So the first question is going to ask if we want to compare our first resource we select to another. So we click solar energy. That's what we want to see. But you can use other resources. So we're going to hit yes, and we're going to hit solar again. And we go to the command window. That didn't work. The first comparison makes sure that this while loop makes sure that the first comparison entered works. This makes sure that this was yes at the start. From here, you see that renewables resource 2 uses the same menu, but the while loop that validates it has this added segment right here. This makes sure that we can't pick the same thing, so I can't pick solar twice, because that makes no sense. So we hit hydroelectric, we go to our command window. If you look at that, it's 3%. So how did we get there? So here's what happened. We went ahead and we used the row number that they were associated with whenever you made the selection into a vector for each resource. We summed every value, and then we summed every value of the non-renewable energy. And from there, we used the sum of all the values divided by sum total, which was the sum of all non-renewable and renewable energy times 100 to give us the amount it was used as a percentage in that 20-year period. And then our if statements. Resource 1 was solar energy. Solar energy was a lot less than hydroelectric. We can view that in the data right here. This never goes above 1. All these go above 1 if you sum them. You can do the logic. But it is in our test case, that is 3%. So I'm going to go ahead and run it again and show the flip side. If we do hydroelectric and compare it to solar, it will use that in that else if statement. Because resource 1 was larger than 2, we're going to run it again. We don't have any data that is equal to each other. We cannot run this. But the nature of this data, that would rarely ever happen. If it does, it's covered. So we're still going to do solar energy. And this time we're going to select no. We're going to view it as a percentage. So let's see what gets outputted. So this is the title of the table. It prints out every year. And what are these percentages? So this was the question. It gets validated. Don't worry. From here, if it was yes, would you like to see the data versus all renewable and non-renewable energy? We have these two empty vectors, and we have this resource vector, which takes every energy value of the row of the resource we selected. From here, we print the title with the resource name, %s, and that's why we had the resource array earlier. Simplify that, and the years. From here, we set the second vector, because why not, equal to the total renewable energy. I'm sorry, the resource energy divided by the total renewable energy at spot G, which is why it's looping through each spot individually, times 100 gives us that as a percent. That gives us this second column. Sorry, this one. And we do the same process, but we add a space for formatting with the total energy consumed, including renewable and non-renewable energies, to get this value. As you can see, it's a lot smaller. This makes sense if you look at our data, but also in our test case, it works. We're going to run it one more time. We're going to hit solar. We're going to hit no. We're going to hit no. We're going to go to our command window. It's going to ask us to input that as a vector. Now, if we go to the data validation, let's make sure this works. So we check the size, not the length, because we need it to be exactly 1 by 2. If it's 2 by 2 and we check the length, we kind of walked into that one. So what we do now is go to our command window, and we're going to input our test case of 0.005, I'm sorry, 0.055, comma 0.098. And from here, as you can see, as said in our test case, we get all solar values, that is every single solar value, plus 2 wind values. If we go to our data set, 0.00, 0.055, yep, and yep. And you can find these 2 wind values in the year 2000 and 2001. We can look there. So wind energy picked up a lot faster than solar energy, if you can't tell, which is why it only appears twice, right here and right here. So we're going to run it one more time. Sorry, I need to open MATLAB. We're going to do another test case that is much wider. I'm picking solar for this, but don't think you have to pick solar for this segment. You don't. Go to the command window. This time we're going to do 2.8, comma 3.25. This will give us a little bit more data. I'm not going to go to the data table to show it, but you can get the idea. We used abbreviations in order to help format the table. So this would be biomass, as said in our data set. And we're going to run it one more time. We're going to also check the second validation of the boundaries input, because our min can't be larger than our max. That makes no sense. So we're going to do, let me show you that it works. Not just with solar. Go to our command window. So we're going to do 101.68, comma 0. And watch what happens. So we don't need to run any more test cases. That was the last one, so we're going to go ahead and view the table. This is printing every single value, and the warning is that the smallest value it entered was larger than the first one, so it just flip-flopped them for us. And with that, that explains our code. I am Max. Thanks for listening, and goodbye.